Conference will now be recorded.
There it is. And will be posted on YouTube afterwards. Everyone who speaks during today's event will be part of the recording. We'll do Q&A at the end of the presentation. If you choose to ask a question, your voice and image, if you have your camera on when speaking, will be part of the recording. If you do not ask a question, you'll not be part of the recording. If you're using the most recent version of the app, which we recommend, you can use the raise hand function to join the queue. If you're using an older version of the app which does not have this function, please use the chat to let the organizers know you'd like to ask a question, and they will add you to the queue. The organizer will let you know when you're next in the queue so you can be ready to unmute your microphone and ask your question. If you don't want to be part of the recording, the organizers can convey your question to the speaker. In that case, please type out your question in full and let the organizers know you would like them to present it to the speaker. If you have any technical issues, please message the organizers for assistance. If you drop out of the meeting and are unable to rejoin, you can post a message on the Meetup event page, which we're monitoring during the presentation. SFPUG, Bay Area Postgres, is a PGUS affiliated user group, and I'm a volunteer for PGUS. SFPUG is sponsored by PGX, and I work for PGX. And without further ado, here is Sam Willis with compiling Postgres to WASM with PGlite.
Hello. Thank you for having me here.
You're welcome.
Yeah, I'm just going to get my slides on. It should be a black screen. If you can see a black screen, we're all good.
Yes.
Good. Okay, so January 2024, Jared Sumner, the creator of the Bun JavaScript runtime, tweeted this: "I wonder when PGlite, Postgres Lite will become a thing. It's an intriguing question. npm install Postgres, a tiny embedded Postgres inside your application." We've been looking at the same problem, but from a slightly different angle. I'm a founding engineer at Electric SQL. At the time, we were building a bidirectional sync engine that does dynamic partial replication and automatic conflict resolution between Postgres on the server and SQLite in the browser or in a local application. But we were struggling. We had a problem with types. There's this massive impedance mismatch between Postgres and SQLite. Postgres is very strongly typed. SQLite is very weakly typed. What is the solution? Well, we were talking to Nikita Shamlagrov, the Neon CEO, and he was advising us about these problems and the issues it was going to cause our users. And he had a suggestion: compile Postgres to WASM so that we can sync from Postgres on the server to a Postgres embedded inside the client application. It would solve all the type issues. You'd have an identical data model both on the server and on the client. He had previously shared this proof of concept created by Stas Kelvich, the Neon CTO, and Jared's tweet prompted me to take a second look. And Stas had actually cracked the very first problem: forking. But first, what is WASM? It's WebAssembly. In simplest terms, it lets you compile your existing software to a format that can run inside a web browser or any JavaScript runtime and even some specialist WASM runtimes. It's a mostly single-threaded linear memory stack machine, and it's been used to port many libraries such as FFmpeg, many games and game engines such as Unity, the Unity game engine. And there's things like Figma, which is a great example. It's a full desktop class web application that runs in the web browser. The rendering engine for Figma is written in C++ and runs entirely in WASM in the browser. But back to Postgres and how it works. As you almost certainly know, Postgres operates under a forking model. Connections are made to the postmaster, and it forks a back-end process that handles the session. But WASM can't fork. You can sort of do multi-threading or using web workers and some other tricks, but there's no concept of multiple processes. that share some memory and share some state. So how did STAS solve that first problem? Single user mode. So this is a special mode for bootstrapping a database with Postgres and for disaster recovery. It offers basic read line input for ASCII queries and outputs in a basic ASCII table format to standard out. It's super user only, designed that way so that it can be used for the disaster recovery, and for the same reason, event triggers and some other features are disabled, so you can't accidentally brick your database. There's no IPC, and there's because of that, so inter-process communication signals. So there's no PG notify, so you can't use the notify and listen tooling that you might be used to. STAS proof of concept compiled Postgres to WASM and could run in single user mode with a very basic terminal in the browser. But you couldn't really use it for anything. It was kind of very much just a very basic proof of concept. So we wanted to take this and make it real. What did we need to get to an initial release, something that people could actually try? So we used the Inscripton compiler toolkit. This actually predates WASM. It was originally a C to JavaScript compiler, but it's really much more than a compiler. It shims libc and brings a bunch of tools to help port the codebase to WASM. And getting Postgres to compile with Inscripton required a few hacks around unsupported features. We had to add a bunch of if-defs to remove code paths that we didn't need or just wouldn't work. The Postgres main loop, particularly in single user mode, is very simple. It blocks on reading from standard in, processes an ASCII query, outputs the results to standard out, and runs looping until exit. But this is also one of the biggest issues with trying to combine synchronous C code with the async JavaScript environment. We need to find a way to pause that main loop. But you can't do that in a single-threaded JavaScript environment where JavaScript has its own event loop. Inscripton actually has a solution to this called asyncify. It lets us await a JavaScript promise inside the synchronous C code. And it does this by using quite a lot of magic. It unwinds the C stack, serializes and saves it so that you can await a JavaScript promise or do some other work before rewinding the stack and continuing. It's a little slow, but it works. Inscripton also comes with a VFS layer, virtual file system layer, which allows us to use standard POSIX file system APIs with backends for an in-memory ephemeral file system, mapping to the Node.js file system APIs for persistence on disk. And it comes with an IndexedDB virtual file system, which is an API in the web browser for being able to persist data to the user's local web browser. So with that, you kind of get persistence for free by just writing to the standard POSIX API from Postgres. Single user mode normally outputs just ASCII tables. And but for this first version, we hacked that so that rather than ASCII tables, it just outputted a JSON string of the results from your query. And then we could easily turn that back into JavaScript objects using the JSON.parse API in the web browser or in Node. So with all that, we actually got it working and wrapped it up into a JavaScript package. So you could just import PGlite, create an instance of it, and then you could run quickly. You could create a table, insert data, query it. And that is a full Postgres running embedded inside Node or a web browser on the same thread as the rest of the JavaScript. There is no Postgres server at all. So we put it online, npm, so it was npm install electric SQL PGlite, and we set it free on the world. And the response we got was incredible. We did not anticipate how well it would be received. At this point, it was still somewhat of a hack, and if you pushed it a little hard, you could very quickly find cracks. It was slow and buggy, and it didn't support basic features like parameterized queries. It was nothing really more than proof of concept, but we were not done, and we were very much motivated to continue. So how did we take this and make it real? Make it more than just a hack? One of Postgres' little secrets, and the reason it's so successful, is the Postgres wire protocol. It's what enables parameterized queries, type support and metadata, notifications, cursors, and lots of other features. Postgres has this great internal abstraction for controlling output and where the output is sent. And we were able to use that to add wire protocol support to single user mode. This enabled parameterized queries and passing columns in the returned data to the matching JavaScript types. So we knew when something was a date, it needed to be passed as a JavaScript date. But there was another issue. Asyncify is actually slow. It's really, really slow. It turns out that unwinding the C stack is something you really want to avoid doing at all, if at all possible. And we were only using it in that one place to block on reading from input on standard in. So we unwound the main loop. We can then have it we can then write the query encoded in the wire protocol format to a buffer, call a new interactive one function that would perform one iteration of the main loop, and then read the resulting wire protocol messages from a second buffer, fully synchronously querying Postgres from the same JavaScript thread. This gave us an eight times speed up over what we had in the previous version. DB is also something that poses something of a problem. Normally, when you run, normally you have to run the separate initdb command, which is a separate binary to create a new database. You don't really want to do that with an embedded database. It should be automatic or an API. And initdb is also quite a complicated multi-stage process. It first writes a bunch of template files to your data directory. It then runs Postgres as a sub-process, remember no forking, in another special bootstrap mode. To solve this, we embedded initdb into the main Postgres WASM binary. It checks if there is a data directory and runs the bootstrap process if needed, and then does a simulated shutdown and restart back in single user mode. We also wanted to make an awesome developer experience for this embedded use case for our users who would be building user-facing applications where the UI would be directly driven from the state inside the local Postgres database. And for that, we wanted live queries. React.js has won the front-end framework battle. If you're not familiar with it, it has hooks that trigger re-renders on state changes. And this is the experience that we wanted to give developers. Write a SQL query in a use live query hook, and it would automatically run, returning the up-to-date results when the database changes. And to do that, we needed pgnotify and triggers. But pgnotify depends on the inter-process signaling in Postgres. It uses OS signals to notify the other processes and pass messages to the other sessions. And none of that works in single user mode. There are no other processes to communicate with. So we patched Postgres to bypass the IPC for notify, pushing the notification straight back to the single connection. And on that, we could build live queries, and that reacted to the database changes in real time. So what can you build with this? We created an example application. This is LinearLite. It's an issue tracker app running on a local Postgres in WASM in the browser. All the state is local, saved in Postgres in the Postgres database. All the queries are reactive and update in real time using pgnotify. The filtering and sorting for the front end is all just SQL. It uses Postgres full text search for its local search functionality. And it's a great demonstration of what's possible when you pair PGlite with a Postgres server via a sync engine. The app syncs in real time with the server and with the other users. This is both the DX and the user experience we wanted to enable. We can have a quick look at this. It's at this URL. I'm just going to swap my screen share for my desktop so I can show you. So if anyone else opens this up, it's at linearlight.examples.electricsql.com, and we can type a message. You'll see it synchronizes in real time with the other browser. So yeah, do log on and play around with it during the talk. We'll swap back. But we were not done yet after building that demo. We wanted to do more. We wanted to see what else we could build. And there's one thing that makes Postgres the best database platform in the world, and that's its extensions. We compiled almost all the Postgres contrib extensions to WASM, including PGSQL. This required making DL open work, as every Postgres extension is a shared library that is loaded at runtime. In PGlite, each extension is a separate WASM binary and linked at runtime. We've built tooling that enables us to find all the symbols that the extensions need from Postgres, ensures that they are exported on that main WASM binary so that the two can link together correctly. We even compiled pgvector to WASM, so you can have a full vector database for building RAG, retrieval augmented generation apps in the browser or any other JavaScript environment. This was particularly an easy extension to port to PGlite, we found. It has no external dependencies, and it's got a really nice clean C code base, much like Postgres itself. So what have people in the wider community built with PGlite? Superbase have created database.build on top of PGlite. It's an AI database designer running fully locally, entirely in the browser. You describe the database you want, and it creates it for you, iterating on the schema, inserting dummy data, and helping to advise and test queries. Lobe Chat is an AI chat app, much like ChatGPT, but your chat history is stored locally in your browser in PGlite. The search features are using Postgres indexes and full text search. Google have adopted PGlite to build the local emulator for their Firebase Data Connect product. It's built into their CLI so that you don't have to run a full Postgres when doing local development. And Prisma have adopted PGlite as the default database during local development. They had the same type impedance problems that we had, and until now, they used SQLite as the default local environment, while often going into production on Postgres. Now, when you're working with Prisma, you don't have to run a full Postgres in Docker or set up a server to match your production environment. It just uses PGlite by default. We're really happy with what we've built. PGlite has grown from a proof of concept a little over a year ago into this thriving open source project. It's been adopted by some of the largest, most exciting tech companies. We're seeing it used embedded in applications like we initially intended it to, but increasingly we're seeing it used in CI and unit testing, reducing the need for full Postgres databases and speeding up test suites. You can fork a full in-memory Postgres database in just tens of milliseconds, so there's no more need for complete databases and schemas or rollbacks. And we're also seeing it used as an alternative to full Postgres and development environments like Prisma are doing. And finally, we are also seeing massive opportunity for PGlite with these AI coding assistants. Platforms like Lovable and Bolt.dev, they need to run the application code when you create your application through their web interface. But to do that, they need a database. And often they have to prompt the user to go out and stand up a Superbase or a Neon database to be able to connect to their coding platform. With PGlite, you can just have that have Postgres run in the same sandbox as the rest of the code. This is a one-shot prompt going from nothing to a fully working wishlist application in Bolt.new. Bolt Sandbox is running fully in the browser, and their backend is a full Node.js development environment running in WASM in the WASM sandbox. Here, PGlite has been used to fully emulate a server-side Postgres so that they can go straight into a working application without having to connect to any external infrastructure. So yeah, PGlite now gets nearly 1 million weekly downloads on NPM, which is incredible. We've never expected it to have this level of growth. And we've got over 12,000 stars on GitHub, if those numbers are important to you. But what's next for the project? This is an image of the Postgres ecosystem that did the rounds a few months ago. Postgres is eating the database world. There's now good solutions to OLAP, time series, graph databases, and many other problems where dedicated database tech would have been used before. Postgres is now a one-size-fits-all database. But there's one place where Postgres is missing, and I think we're on track to have the answer to that. libPGlite. Our ambition is that PGlite graduates from WASM to becoming an embedded library mode for Postgres. We want to make it native and as portable and embeddable as SQLite to bring all the power of Postgres and its incredible ecosystem of extensions to native apps. There's a lot to solve to get there, and there's much crossover with many of the other things that are happening in the Postgres ecosystem. The various pluggable storage backend proposals that have been made would help solve a VFS layer, enabling something like the SQLite VFS layer. And the possible move to a threaded architecture in Postgres, while after many years of looking very unlikely, is now actually looking quite likely with a branch that's being developed by a number of the core developers. That will enable us to much more easily offer a multi-user mode to PGlite. So this is going to be a long-term project, but I'm determined to make it happen, and I want to work with the wider Postgres community to do it. And I want to say thanks to Suz Kalvich for creating the proof of concept that kicked this project off, and my colleagues Steph, Paul, and Tudor for the work they've done to make it real, and many other contributors in the wider community to build PGlite or build the community to where it is without them. So please do go on and look at PGlite, check it out. It's online at pglite.dev. And I'm looking forward to answering your questions, but I want to leave you with one final thought. What would you build with PGlite, this embedded library mode for Postgres? Where would you be able to put Postgres that you've never put it before? Thank you.
All right, do we have any questions? Great talk, Sam, by the way.
Thank you.
I'm not seeing anything in chat. No questions?
Gosh, must be a few. Maybe everyone was at Postgres at PGConf in Montreal, and they all asked their questions there already. Who knows?
Tobias says, run Postgres in Postgres using PL/WASM, smiley face.
Oh,
impressive work, thanks.
PL/WASM's probably not going to happen, but I'm fairly confident if we wanted to, we could run Postgres in Postgres with PLv8, because it would bring all the JavaScript wrapper as well. I'm not sure if PLv8 has WASM. I'll have to have a check. You made me think of something that might go viral on Twitter. I'm going to have to go and have a look.
And Quinn said, I'm curious about performance considerations when using an embedded DB in a test environment.
So it's certainly not as performant as native Postgres. It's probably sort of 3 or 4 times slower than a fully native Postgres. But where it really shines is for smaller unit tests. If you all of the friction that people have had with testing database queries is the fact that they've had to stand up a full Postgres as part of their unit testing suite if they want to unit test Postgres queries. With this, you can stand up a Postgres in 300 milliseconds, load some small amount of data, run some queries, test your stored procedures, test your PLv8 code without having to sort of jump outside of your test suite.
Very good. Brian L. asked or commented, I'd followed Electric SQL. Whoops. Yeah. I followed Electric SQL for a while. I work on an app that is for energy audits and uses an API-based offline first strategy. It's good to see this maturing and gaining momentum. I see something that works better than the Realm Sync thing I have going.
Great. Well, do reach out to me or jump over onto Electric SQL, the Electric SQL Discord. The rest of the team are there to help as well. We're doing well. Electrics is growing, and we're seeing good traction. So we see PGlite as it's one of the targets for Electric. You can sync into PGlite, but you can sync into many other things. And for the kind of offline persisted sync, where you want to be able to replicate your local environment and your server environment, it's kind of perfect, really.
Bear has a comment, or actually a question. Comparison with test containers managing a Docker image containing real PostgreSQL server?
I've not used test containers, so I don't feel like I'm educated enough to be able to say how it would compare. My impression is that test containers are more for kind of end-to-end tests, whereas I think PGlite is better for kind of the more granular unit tests.
And Quinn commented, we're on the same page then. Thank you. Great to have an option like that.
Great. Thank you. Yeah.
Perfect. Any other questions? Doesn't look like we do. I think I got to everything on there. Okay. All righty. Thank you again.
May have been slightly shorter than some of the other. My talk might have been slightly shorter than some of the others. I feel like I've kind of pushed through that quite quickly, but I hope it was interesting.
It was interesting. Yeah, there was a lot of really good information in there. Thank you, Sam. All right, and thank you also to PGUS and PGX for sponsoring. Our next PUG will be on August 12th, where we'll be celebrating World Elephant Day by presenting Story of the First PG Day with Federico Campoli, and Join the Herd, How to Get Involved with Postgres Community with Stacy Hazler. Our upcoming conferences are FOSSE, which is July 31st to August 3rd in Portland, Oregon. PGConf NYC will be September 29th through October 1st in New York City. And PGConf EU will be October 21st through October 24th in Riga, Latvia. We'll send a link by email when the video is ready, and watch our social media. You can find us on LinkedIn, Mastodon, and Blue Sky by searching for Bay Area Postgres. We are looking for speakers for 2026, so if you or someone you know is interested, please contact us. Thank you again, Sam, and thank you all of the attendees, and hope everyone has a great day or great evening, as it may be.
Yes. Thank you very much for having me.
Thank you.
I've really enjoyed it.
You're very welcome. Thank you.